While you may have found the solution, there's a new function that I haven't taught you yet called map. All right, and what map does is it applies a function to every item in the list. Okay, so let's go ahead and make a new function, and this function is going to be called replace if meet. Okay, and it's going to take a string, which I'll call it, and it's going to output a string. Okay, doc if meat, make it tofu, else tell me the veggie. Okay, where, let's go ahead and give ourselves some examples. Replace if meat sausage is tofu. Should be lowercase sausage because we got rid of all the capitals. Replace if meat peppers is peppers. Okay, so looking at this, we very simply have an if-else structure of some sort. So let's go ahead and write our if-else. Okay, we have if, we have else, we have end to end our block. Okay, and we know if and else, we need our colons. So if what? Well, if it's meat, we want it to be tofu. How can I check if something is part of the meat list? Well, I can use my l.member. And my l.member, I'm going to look at my meat list, and I'm going to check it against my string. So this is just checking if it's true or false. And if it is true, we want it to tell us tofu. Else, we just want to tell us the string. Okay, let's just run this, make sure we have no errors as now. The only error I can see is I have l.map by itself right there. So if I go, so it passed our test, our replace if meat works. So now I can l.map, and I can go ahead and map onto my tofu list, my vote list, the results I want. All right, so I can, excuse me if I don't remember the order, so I'm just going to go, what was it called, pizza vote, and I'll use replace if meat, run it. We have an error, and that's most likely because I've just put the function together backwards. Let's go ahead and try that again, and it works. And now you can see that it results in tofu, peppers, onion, peppers, egg, tofu. So all of my meats have been changed to tofu. Egg is kind of weird. We didn't put it in our meat list. We'd have to add it to our meat list. But as we can see, by using this map function, I'm taking my replace if meat and I'm applying it to every item in my pizza vote list. Okay? All right, let's go ahead and try another one. I believe this is, oops. Okay, I'm just copying a problem from over here. Okay, we're texting your best friend with a new messaging app called Flower Power. Flower Power is the coolest app ever made, and its users love it. It only accepts shortened slang. You need to shorten the user's message. Let's just start with some basic examples for R and U. So are you home should be are you home, all right? So we know we have some sort of function. I'm just going to call it shorten. It's going to take in a string. I'll call it str. And it's going to output a string. Doc change R to R. Change U to U. Change, was there a different one? 4 to 4. Okay, ... I think you guys can see the bottom of my screen right now. Yeah, it's a little big. Let me, give me a second. I'm going to fix that. Still a little big. That's closer. Okay. But I'll just bring it up. Okay, we need some where examples, so shorten 4 is 4. Shorten U is U. Shorten for U, and what was the other one? R is R. And any other word should remain the same for now. Shorten dog is dog. I want you to go ahead and pause the video, try to figure this out, and then we'll do it together. Okay, the only other assumption we need to make is we know that they're going to give us a list of words. So we know if we're dealing with a list, we're going to be dealing with map, and we're going to be dealing with shorten and word list. Okay. Now, let's go ahead and play with this. Okay, so we know we're going to go into some sort of if here because we have different situations. Is it if else or else if in pirate? I believe it's okay. Different languages have different ones. 1, 2, 3, and else. Okay. Else, if it's not one of our keywords, it's going to give us our string. I think we're all okay with that. If. So, what can I use to detect the string here? Well, we can just use a simple equal equals. If the string is 4, then what should it display? It should display 4. Else if str equals U, it should be U. Else if string equals R, it should be R. I guess I'm just going to make this capital. And I'm just going to turn off my map for now, just make sure everything else works. Shorten, so 2 out of 4 of my tests passed, that's good. Okay, I wrote a bad test for these two. That's good to catch. And now everything works. Okay, so now I'm just going to go ahead. I'm going to make a list of words. I'm going to call it word list. And it's going to be equal to a list, which is going to contain the phrase you are my best friend. Make it something wholesome. Okay. Let's make sure this works. And we can see that it works. You are my best friend. So our LMAP worked here. Okay. So that is one way that we can solve that problem. So let's go ahead and talk about what LMAP is really doing. What LMAP is really doing under the surface is this. And I'm over here on the left here, on the right. So list, I'm going shorten R, shorten U, shorten my, shorten best, shorten friend. Oops, and I forgot to close my list. Okay, that's what map does. It says take this shorten and run every item in the list through shorten. That's what it's doing. Okay, so if you're ever confused on how map works, that's what map means. It maps the function to every item in the list. Okay, next thing we need to know is how to access our lists. So I have a list up here called meet. I'm just going to cut it and bring it down just so we can see it as we do it. Okay, I don't actually have to do this. I'm just doing this to make it easier for us to read. So while list might look like one group, it's actually a whole bunch of items, and some languages have really good ways to access it. In Python, for example, you would type something like this, which I think will error. Yes. No, it's actually causing an earlier error because meet happens after using it. So let me bring this back down. Meet 2. Okay, so I could try something like this, which is how we've learned to access it in tables. This is how Python does it, but it's not really what's happening. Okay, What's really happening is I need to run a command like this first, and we can see it's stake meet.first. Okay, well that's how I get to the first item. How do I get to the rest? Well, I have meet.rest, which is the rest of the list minus stake. So how do I get to pepperoni? Well, I get to the rest of the list, and then I look at the first item of that list, which is pepperoni. And I can even look at rest.first.rest, which is, oops, meet.rest.first. And so on. Don't worry about that error. I'm gonna explain it in a second. Okay, I threw some slides together to explain it. I think it'll be a little easier. So, I have a number list, 3, 4, and -1, and we're gonna make an aggregate function out of this. An aggregate function is a function that runs over a list in this case, okay? So, my function is product. Yes, I'm doing multiplication. I'm gonna multiply the numbers of the list together. So I need to go ahead and make my function and make some examples. So if my list is 2 and 3, it'll give me 6. If it's 2 and 0, it'll give me 0. If my list is empty, it'll give me 1. Why is it going to give me 1? Because there's no other items in my list, okay? So if I look at this list and I type numList.first, what will it give me? Let me just go ahead and copy this over to Pirate. Numlist. If I go num-list.first, what will it give me? It will give me the number 3. Okay. How do I get to the 4? How do I get to -1? To get to the 4, I have to type numlist.rest.first, so it's the rest of the first. To get to the -1, I have to type .rest.rest.first. Okay? So let's find the product. Well, we know that in order to get to these numbers, we have to get to them, right? So I can go numlist.rest.first. That'll get me my 4. And I can go numlist.rest.first, which will get me to my -1. Okay. So mathematically, to multiply these together, and actually, let me just do this product. Did I say? I just want to make sure list. LST, which is going to be a list of numbers. And what's the format for that? Sorry, it's just been a while. Capital list numbers in. Give me a number. Where product list 3, 2 is 6. Product list 3, 0 is 0. Product list no list is 1. Product list 4, 2, 2 is 16. Just run it, make sure we don't have an error. We do, because I have this here. This should be this, wrong language. I think they need a space. So, okay, we have a slight error there. Let me just double check myself, just because I'm going. Oh, I forgot to put them in brackets. And thank you, end. Oh, typo. This is why we do all this testing. Is it number? Capital N number? Yes. Okay. So, as we were just saying before this, and sorry for this, in order to get to my num list, it's really num list times first. So if I wanted to multiply the numbers I made earlier, it'd be num list times first, num dash list dot rest dot first, and num dash list dot rest.rest.first. And let's just make one of these happen before the other ones, and I can get that -12 I was looking for. So the question is, how do I tell the computer to access these layers, and how do I tell it how many layers there are? Well, what we have here is a form of a tree. I have my product list. I have list.first, list.rest, list.rest.first, list.rest.rest, list.rest.rest.first, list.rest, etc., and so on. So really, there's not a shortcut to this type of problem, and we have to solve it in a special way. All right. We know that if the list is not empty, then the list is the list's first item times the product of the rest of the item. So a list can have either two states. It can be empty, or there can be a item in front of another list. So an empty list, or there's a link, an item, comma, list. So when we see list 2, 3, and let me go ahead and just, actually this is fine. When we see list 2, 3, what we are actually seeing is we're seeing the command link. I'm linking 2, comma, link, comma, 3. Okay. Oh, I forgot empty. Because the lowest level link has to have an empty, and empty means there's nothing there. And that's what a list actually is. It's a linked list. It's a whole bunch of links put together. So my num list is actually link, comma, 3, comma, link, comma, 4, comma, link. And inside this link, I have -1 and empty, because empty is the lowest level of my list. Okay? So link is a function that connects things. List is a shortcut to it. Okay? And really what we have is we have link first, our 2, and then, for example, we have our rest, the rest of our linkage. Okay? List is actually a shortcut for link. Okay? So if we look back at this product table that I was showing you earlier, what we actually have is a situation. And this situation has two cases if we want to do something to a list. Okay? And I'm just borrowing syntax just because that's the part I tend to forget. Cases, list, link, list, lst. And we have a case where it's empty, which I believe is syntax is this. No. Oh, it's the other way. Wrong language. Empty, which will give me this. And we have a case where it is linked. Okay, in this case, we're linking first with the rest. Those are just shortcuts in terms of first and rest, where something happens. In this case, we have our first times the product of our rest. So, in this case, if our list is empty, we've already done an empty list, it's right here, then the result is 1. Okay? Because when we multiply a number by another number, we don't want to modify it, we multiply it by 1. Okay, on the other hand, we're multiplying the product by its cases. Oh, I have a syntax error. There's no semicolon there. Okay, let me just check these. Equal print. Why did empty not work? Give me 1 second to try to figure this out. Okay, this error is pretty simple to fix. There's just no colon here, and this is a block, so it should have an end here. And we work. Our product works, so I can go product, and I can tell it a list. And my list will have 4, 5, 6, 8. Lists need brackets, and it'll multiply them together and give me 960. So let's talk about what's happening. I know I just typed a lot of code and this is confusing. This is a big jump in learning. Okay, this is the new concept. So cases. So cases like an if statement, and saying if there's empty list, give it the number 1. However, if there is a list that's linked with first and rest, then take the first item and multiply it by the product of rest. Well, Mr. Flower, what's product? Product is our function we're making here. So let's go ahead and look at this list here, this product list I just tested. So product comes in, it looks at the list. Our list is 4, 5, 6, 8. It takes that list and it checks, is it empty? Is it empty? Nope. So it's going to check the link of first and rest, and it's going to take the first number, in this case 4, and it's going to multiply it by the product of 5, 6, 8. But Mr. Flower doesn't know the product of 5, 6, 8. Correct. So it's going to take 5, 6, 8 and make that our new list. So is 5, 6, 8 empty? No. Okay, so then it's going to multiply the first number, which is 5, times the product of 6 and 8. 6 and 8, etc. So it's going to work its way all the way down. So 8 times 6, 42, 42 times 5, whatever that equals, times 4, and it's going to give us 960. But Mr. Flower, what happens when it's empty? It takes that 960 and it multiplies it by 1, which doesn't change its value. For example, this is going to make all my math wrong. It's going to give me a nice red block, but if I do this now, it'll give me negative 960, because I told it if it's empty, give me negative 1. Okay. So let's just try something easier. I think multiplying is harder, but I used it as the first example, so you can try to do the second one by yourself. So let's go ahead and do sum. So same thing. We can even grab the same, basically everything. Let's just do that. Where'd my sum go? Sum cases, there we go. Where we just need to change all these products to sum. Okay, so let's start off with this one, because this one is special. If it's empty and I want to add something to a number and not change its value, what can I add? I can't add 1. 1 changes its value. I'm going to add 0. Okay, 4 plus 2 plus 2 is 8. 3 plus 0 is 3. 3 plus 2 is 5. Okay. So, empty. If it's empty, what should it give me? Well, we just made up the rule for that. And actually, let me copy the rest of this in. If it's empty, it's not going to add 1, it's going to add 0. Okay? And we have our first and our rest. If we're going to do addition instead of multiplying our first, we are going to add it. And we have an error in this program, and that error is because we never ended the program. Boom. Our sum works. So I can go sum list 1, 1, 1. Okay, it's telling me 2. We have a problem here. I wonder why we have a problem here. 1, 1, 2 is giving us 3. So our sum isn't working how we expected it. We have a slight problem. Try to debug it and figure out why. All right, you guys are smart kids. I was telling it to multiply the rest. Add the first number and then multiply the rest. We actually want the sum of the rest, so let's try that again. And now if we tell it to do sum, it does it correctly. Okay. You might see this diagram. This is called a function call diagram. This shows how it goes every round. So in this case of our sum, it takes sum and it just keeps ripping out the first number and adds them all together until it gets to the empty, which is 0, and adds them together. Okay, how to write one of these functions. Name the function. Write your where blocks. Copy the case structure. So the case structure is this empty link thing that we did. Okay, so I want you to go ahead, try a problem. I'll show the answer in a video. But I want you to try to write a program that will tell me the total character count of words. So basically, how many words are in a list? How many characters? How many letters? So if it's A, B, B, C, it should be 4, okay? This is the shell of the function. I guess I can copy it over into Pirate because I'm going to use it too. Your job is to try to figure out what happens with my empty and my link here. Go ahead, and I'll see you in the next video.